everybody, welcome back to week 2. So we are now perfect. Sorry about that. As you may have gathered, we've had a couple of technical challenges to come live to you this morning, afternoon, evening, depending on where you are. But we're in live. So one of the small challenges we have is, unfortunately, we've just got a picture of Alex today, but you will be able to hear him speaking. So you'll hear the voice of Alex, but perhaps less sort of movement from Alex. But it's all good. Don't worry. We're all here. Well, I'm sure we'll be back sorted next week with it all working tickety-boo. Okay, so we are here with week 2. So the plan is we are going to go through the week 2 challenge, and then we're going to cover the solution. So for those of you who can only hang around for a short period of time, you can get the information about the week 2 challenges, and then for those of you who can spend a bit more time with us, we'll then be going through the solutions or potential solutions from week 1. So, exactly, stick around if you can. Good stuff coming. Right, let's get moving. So, quick reminder about Summer of Notes. So, this is week 2 of 4 weeks of challenges. And the idea is we've got something both for beginners and for experienced. And there's something to be learning. So the idea is we want this to be fun, and there's lots of opportunities to learn. So last week, as an example, for those of you completely new, you had an opportunity to learn a bit more about data modelling. For the more experienced, we threw a right curveball at you, I feel, with the challenge where we're using APOC and our knowledge of cipher to try and solve it. Almost like you probably unimagined applications of cipher for experience. But the idea is, hopefully, and certainly we get the impression of some of the feedback, so thank you very much for those of you who've been leaving feedback. Hopefully you've been finding it fun. So that's the Summer of Notes. And as a quick reminder, there are prizes to be won. So we've got 100 stickers that we are giving out. So these are unique. We're not giving them out to everybody. If you get one of these, it's going to be a rare thing. We're not handing them out to everybody. And exactly, limited edition sticker. And for those of you, we've also got this special backpack filled with goodies. And we're going to be giving those out randomly, 1 per challenge. So we have 2 challenges per week, so 8 challenges in total. So we have all of these to give out, and we'll be announcing the winners of those for week 1 today as well. So keep your eyes and ears peeled. So a quick reminder as well about our schedule. So Monday, so this is the slot now. We effectively are going to give you a description of what the challenge is going to be for the week. We're going to give you an example of the solution you could have used for the challenge, and we'll also, shortly after the stream, publish the blog post. In fact, I've already published ahead of time, and we just update the links. We also email all the registrations shortly after the stream to remind you of all of those important links. On Thursdays, exactly. So Alex has got his finger hovering over the magic send button, and that's exactly then a good reason to register. We remind you when stuff's coming through. On Thursdays, that's our second stream for the week, and what we do is we give you some hints. And also, if you've been posting questions in the forum, if there's a common theme coming up, or maybe we've not explained the question well enough or something like that, then we'll also pick up on there as well. And if you've got any questions as well, generally you want to ask us during the live session, that's a good time to ask those. And again, we'll update that blog post that we published on Monday. We will update with any hints that we provide. And don't forget, on Sundays, with the times that we've there, that is the cut-off. If we receive any solutions after that cut-off, I'm afraid we can't answer them. So do get your answers in before the submission. And just a quick reminder of those all-important links. So some of you are watching us on live either on Twitch or YouTube. According to the feedback that we've received, apparently Twitch is a better live stream experience. I don't know. So we go live on those. So those of you who are catching up on the recording and want to watch us live again, you've got the option there. Also, that's the link to the blog post for week 2, so you can actually go to that link now. I will just update the links once we finish the stream. The sandbox. Sandbox is a great way to do these challenges, especially for this week, so you've got the address there, and you've also got the quick address to the forums. If you've got any questions about the challenges or in general, want to raise anything, that's a great place to do it. So, let's move on to week 2 challenges, the online day out. So I'm going to hand over to Alex. He's going to... Okay.
Nobody.
So those of you on the stream, we're going to start back from the start of beginner's challenge. Sorry about that. Over to you, Alex, for the beginner's challenge.
Yeah. All right. Sorry, guys. But I mean, it's good because obviously my face is frozen. So why shouldn't my voice also be frozen? That's what happens. Now the video is clear. The cam is not working today. I don't know what's going on. So I had to use this snapshot. So I pretend. But sorry, the technical difficulties were really hampering us today. But if sounds good, that's the point. Exactly, it's an image. All right, so back to the beginners challenge for this week. So I was saying that when you are going on holidays and if you go to a new city, some of the usual stops for me are 1 or 2 museums when I'm there to see what's in stock at these different museums of art or of science or of whatever fashion. But now when you are not really traveling that much, you can explore the cities in your hometown, but you probably have seen them already. You have been there. I'm based in Munich, and I've seen them all at least one time, maybe a couple of times as well. So I'd like to see something new. And Lou found that the Metropolitan Museum of Art in New York has this great online repository where we can basically download and look at the whole catalog of their inventory at the museum. So you can really explore the museum on their website without having to be in New York, which is super good. And we will use this repository for this week's challenge and using it to import this data into Neo4j, make it into a graph, and then you will have the task this week to explore it in Bloom. So Neo4j Bloom is a visualization tool which we launched a couple of years back. And the goal of Bloom is really to help you explore and visualize a graph without the technology behind a graph data. I mean, there's the technology of a graph database behind, but without you knowing all of it. So you don't have to do Cypher queries. You don't have to explore it with the browser with lots of programming, but you can just type in search queries, easy texts. It's autocomplete. It suggests sometimes some text for you. So you can really explore a graph without writing much in terms of Cypher or any other programming language, which helps you a lot. As a stepstone into the world of Cypher, into the world of graphs, I think it's a great vehicle. A, for people who don't really are that comfortable of writing code, and B, on the other side, for people who want to learn but want to go gradually from, like last week we did the modeling, this week we go into Bloom and a little bit of Cypher. And so step by step, you will explore further how this whole Neo4j ecosystem works, and you will learn from week to the other a little bit more.
Exactly. So it's just gradual steps, baby steps.
Yeah.
And we're giving you, so we are giving you the instructions. We give you the script to load the data. So you don't have to worry about, how am I going to do this? But of course you can have a look and see what we've done in there. And then, we've got lots of links and resources that you can sort of use so you can get familiar with using Bloom. So you're not out in the cold.
Yeah. No, we have lots of like you say, links and guides. So there's a starter guide for Bloom. There's a Twitch. Lou, you did a build up how to build a perspective in a stream earlier here on Twitch. There are tips and tricks, blog posts. So we have lots of guidings for you, so you don't have to start from zero basically.
And we do have a quick start video. Sorry, I've not put the link in here, but in the blog post all the links are there. And again, if there's something there, you're confused, we've not covered it, put a message in the forum and we'll help you along. So this is all about learning in a fun and, in an encouraging environment. So if we've not covered it, then do it. And I think the really cool thing about this challenge, Alex, I think as well, is there is probably quite a few experienced people who have not used Bloom yet. And just as a quick reminder, So for the experienced amongst you Cypher warriors, if you've not come across Bloom yet or have not had the opportunity, now's a great chance as well to have a go.
Exactly. And everybody can do. I mean, you can. I think we talked about this earlier, but the Bloom or any any challenge here in the Summer of Nodes, you can do both experience and the beginners tier. Obviously, you can only win once in one tier, but it's no harm in sending us answers for both of these two types.
Exactly. It's a good way to set yourself a challenge to try and complete something. So having a target there. So absolutely. And I think so please do have a go. A lot of fun. So no reason why it's just the it's not just the just for the beginners. It's good learning opportunity. So a bit of fun with that. So yes, we've got the actual challenge. So Alex, tell us more about it.
We should probably talk a little bit about this.
Oh, absolutely.
We have a couple of questions for you. Depending on the database data set we have for you. So we would like you to create a Bloom perspective for us. You can do that from any of these following questions, which give you a visualization back of a graph, and then you can take a screenshot and send it to us. So the first question would be, how many different classifications are there? I mean, these questions will make sense if you look at if you start Bloom and generate a perspective and look into the different labels. So obviously they are about paintings, different kinds of paintings. They have different types of classifications. These paintings have names. These paintings have things on them, obviously, and you find this in the data set. And another question is how many paintings have more than one artist. So that's always interesting if there have been collaborations between different artists and they created this one painting together. Then one will be, what instrument is in the painting found in the musical instruments department? So obviously the musical instruments section has also paintings, and these paintings will have musical instruments on them. And there is one, particularly in this data set, and you have to find this and tell us what is on them and what kind of musical instrument is on it. And then we would like to know how many painting titles start with Harbor. So as I said, every painting has a title, and they call it the Duke of Edinburgh or whatever. But some of them start with Harbor, and we would like to know how many of those start with Harbor. And I mean, this is for the Cypher warriors. You can answer all of these questions with Cypher in Neo4j browser, but this is not the point of this challenge. So this is really, you should do it in Bloom. So please use Bloom phrases for this and explore and play around with Bloom a little bit. So if you know, oh, you can answer this all in Cypher in browser, yes, we know you can, but you should not for this one.
Yeah. This is all about getting comfortable with working with Bloom.
Yeah, exactly.
And certainly from my perspective, what I really like about Bloom, so I'll be the first one to jump and pull together a Cypher query, but I find Bloom really useful for certain types of queries where I'm kind of like, that's going to be a fairly long-winded Cypher query, right? But I just fire up Bloom and I can quickly explore my data. And when I've got an idea of what I'm looking for, then I'll go away and write my Cypher query. So it's really good for that as well. So it's a data discovery visualization tool, but you can use it to just as a even if you're sort of thinking about it from a I'll kind of go, is it going to be quicker for me to find out my answer in Bloom or browser? Right, I'm going down Bloom. So it's really cool for that as well. So it's really worth just having a play and looking at it. So even though, because like I said, you can write a cipher query for it, but you can do it in Bloom as well and have a play and see what works for you.
Yeah, exactly. And sometimes you think, oh, I know how to do this in, let's say, browser, because I usually work in there. And then you realize, actually, like you said, this is much easier in Bloom. Why haven't I done this before? Yeah.
Probably worth talking about sort of what we're looking for as well, Alex.
Oh yeah, the extra credit question maybe quickly is we add a search phrase, so you can add cipher search phrases in Bloom. So this is a little bit more advanced. It's not a really tough question. I think it should be easy to answer for everybody, but we have decided to give this the extra credit label. So this means that the other ones before mentioned questions, you have to give us an answer to in order to win. If you go the extra mile and answer the extra credit, you get obviously brownie points for that. But if you struggle with it, or if you can't solve that one, you are excused, so it's fine.
And at least have a go at it. So,
yes.
Because what we ask for, because we ask you to give us a title of paintings, but have a go at trying to write that cipher query. And the reason why I say that is because next week, the Beginner's Challenge, we are going to start doing a little bit of cipher. We're slowly building you in. And if you can figure out how to solve that search phrase this week, you've got a massive step up for next week. So do have a go at it. It doesn't matter if you don't quite get it right, but that mechanics, that stepping through that learning, will be very helpful for next week's challenge. So
yeah. And if you don't get it right, and if you struggle, send us what you came up with. Send it in the form, so we can have a look at it, and we can maybe find out if there are some common problems people had, and then we can talk about this in the next stream. So send it in.
Absolutely.
Yeah, and what are we looking for exactly? So if you start up Bloom and if you generate your perspective, you can set up a few things, and we would like you to do that for this data set. You can select icons for the different categories you will see. So play around with that, find icons that work with the different names of the categories, and assign those.
There is an artist icon in there, and there is a museum icon in there. So there are some fun icons. So you'll probably while away 10 minutes looking at all the fun icons.
Yeah, it's a huge set of icons. So I think I did the stream video game Steam library thing a couple of weeks or even months now ago, and I was thinking, there probably isn't an icon for that, and surely there were icons that were perfectly fitting for this. So
absolutely.
Yeah.
Sorry.
And obviously, no, it's fine. Sensible captions on display for the categories. So if you set up your perspective and you send us the screenshot, we should see something on it. So it doesn't make sense if you just see some kind of indescript icons or something very far away, so we can't really say what you generated here. So zoom in a little bit so we can see what you decided, and obviously answers to the questions. So send those.
That would be good.
Yes, that would be good. Okay.
So what's probably worth mentioning a little bit here. So don't worry, all the links are in the blog post. So we're just posting these here so they exist, but all the links are in the blog post. And we also thought it might be a little bit helpful if you've got a view of the data model. So this is the model that we're using for the Bloom. So here you can see all of the property key names. So those are all the things on the left. So ID, title, date from, etc. for painting. So you've got all of the relationship names there. You've got all of the node labels there. You've got the property names in use. So if you need a little bit of help, if you need like a little map to help sort of navigate yourself around what's connected to what, you've got that there if that's helpful.
Yep, exactly. So I think that's helpful. And one other thing, you have to load the data into a blank sandbox or your local instance, but you don't have to worry about the code. So just open the link that Lua has provided here, and it's a couple of queries. You just copy and paste them over and execute, and they will then fill in your database. You don't have to worry too much about what it actually is, but you can obviously learn something about it, how to get your data, how Cypher looks like. So if you are completely new, read through these queries. If you don't understand them, that's fine, don't worry. But if you will find out that it's fairly self-explanatory what's happening here. So even if you don't know any Cypher, if you don't know what's going on usually behind that, you can derive from reading what it probably means, and that's probably then what it actually means.
And I guess what we can do on Thursday in our hint section, so if you're struggling a little bit with the loading the data and starting up a sandbox, we can cover that on Thursday. We'll show you step by step how to do all of that. So we'll give you have a go first, and if you're finding it's just not working for me, then tune in Thursday. We'll do it together.
Yeah, exactly. That sounds like a good plan.
Brilliant. And again, we've got the link to the answers. And please be registered. You need to be registered for us to accept your answer for the prizes and that kind of thing. So if you're not, again, if you just want to, play along, you want to have a go at the queries with no commitment, that's completely fine. But if you are looking to have a go at some of the prizes, then you do need to be registered. So please make sure you've registered, and make sure that the email address you use when you're submitting your answer is the same email address you use to register. Cool.
Yep. The link is in the chat.
Yes, thank you very much, Alex. And you got the link there, so thank you. Right, on to the experience challenge. So this is going to be a little bit easier, but last week was fun as well. But this one's also a fun challenge. So we're going to be using the same data set and this fantastic the Metropolitan Museum of Art in New York. Something to mention quickly, so the data that we're using for both the beginners and the experience challenge, so this is a subset of the main CSV. So if you go to the repo, and we've got an address in the blog post as well, if you're interested in having a look at the full data set, please do, but for the purposes of these challenges, please use the subset of the data that we've given you. And that, specifically about that subset, it's everything that's a painting is in that subset, and everything that is open access. So everything that everything that's like freely accessible. So that's the slight difference there, but please only use that data set. But we're going to continue using this data set, and what we're going to do is we're going to build upon what was started off in the beginner challenge. And there's a reason to this, because you and a group of friends have agreed to do a virtual viewing of the Metropolitan Museum. So you're going to gather around your video conferencing software of choice. So maybe Google Meets, I don't know. But you're going to be gathering together, and you are going to be looking at a few paintings. And with those few paintings, you've got to decide what are going to be those paintings, because you're not going to look at everything. There's 4,000 paintings. That's a lot. That's going to be a pretty long virtual viewing. So you want to really narrow down the number of those paintings, and you're going to do that by using the graph. So you're going to do a bit of research. You've gone around. You've asked your friends what they like to see, and then, based on those requirements, you're going to do a bit more processing with the graph, and then you're going to answer those questions. So let's have a look at these friends' requirements. So you're going to be doing this viewing part. There's a group of you, and we've got Freya. Freya loves to see the use of gold as a medium in paintings. Grace likes those really big paintings, those extra large paintings. Tarek likes paintings from the Romantic period. So for the purposes of this, you're going to assume again, if you remember the data model, we had artist end year, so that's the artist's year of death. So for the purposes of the Romantic period, assume the end year fits within the range provided. And Matteo likes to see paintings with birds. So you've been given these criteria, and what you need to do is identify all of the paintings that have at least 3 out of the 4 above criteria. So anything that meets 3 out of those 4, you want to grab all of those paintings. So same idea, we're going to provide you with the data there. So you've got the link again, that's in the blog post that follows afterwards. So don't panic, it's not like, you're not expecting to quickly scroll down this link, we're going to provide that. But you need to meet those requirements to get 3 out of 4. And talk a little bit about what we're expecting. So you may use the standard Neo4j plugin, so things like APOC. If APOC is going to help you, then go for that along with the other things. What we want you to do, so you'll have a look at that CSV that we provided a link for, and you will need to tokenize, or we're expecting you to tokenize the medium, tags and artist. You'll need to be able to do that to answer the questions. What we want you to do as well, we want you to process the size of the painting into those specified buckets. So you can see we've got an extra large bucket there, and that's 11,150 centimetres squared and greater. So we're going to make it a bit easier for you. So when you look at the CSV, so again, we can do more detailed analysis of the CSV in the hints session on Thursday. But when you look in the CSV, you'll notice there's dimensions field there, and you've got some settings there. So we're going to make it a bit easier for you, because what you'll see is that sometimes it's only got one dimension, which is the diameter of something, so you can ignore those. You'll see some of them have got 2 dimensions. Happy days, that's brilliant. We treat that as width and height, and we multiply those to get the area. Some of them has got 3 dimensions, so they've also got depth. So assume the first 2 out of the 3 dimensions are the ones that you want, and again, treat as usual. Some of them you've got multiple dimensions, because actually it's several fragments of a painting, and they sort of say, well, actually the first measurement is what we think the complete size would have been, and that's, again, in that situation, just take the first one. It's a bit interesting, that data, so please only use this regular expression that we've provided. So you'll more than likely be using some of the APOC text tools, and that will be useful for you. So please only use that regular expression that we have provided for you, and only use the first dimension that is returned using that regular expression. Moving on. Avoid any paintings that don't have at least one clearly named artist. So if it says, unknown or unnamed artist, ignore those. You may reuse the import script from the beginner's challenge. So if you find it helpful to take the import script that was used for the beginner's challenge and adapt it for the purposes of this challenge, please do. You're more than welcome to do so. And what we want as an output is the answers as a list of painting IDs. So you'll notice there is a column in the CSV which is called object ID. So that's what we want a list of. So that's going to be a list of the IDs where at least 3 out of the 4 criteria have been met. So this should be good fun. So we'd like you to do that. And again, you're going to be submitting your answers to that form. And again, you need to be registered for your answer to be accepted. And so that's the experience challenge. But we have a big ask of you before we move into the solutions from the previous week. This is your Voyage of Discovery 2. Something that really struck us, and I'm sure you found the same, Alex, is that there is some amazing paintings in this collection, and even in this subset of data of around 4,000 paintings. There are some really lovely things to see. And if you've gone to the effort of processing that data, and this is true for the beginners as well, so even with the beginner's challenge, you can still explore the paintings by looking at certain artists or departments or the titles. But this is a really great way to just explore paintings based on things that you like. So I'm a big fan of some of the Japanese art where you have animals like birds in them. So it's an easy way when you've done that processing to explore. And something as well to bear in mind is you'll also notice that there is a URL available on the paintings. So we've already imported that for you. If you look at the beginner's import script, we bring that in. Go and have a look. You can actually click on that URL within Bloom or within browser, and you're going to bring up that page, and that page will take you to the specific landing page for that painting at the Metropolitan Museum, and you'll get description. You get to see that piece of art, and it's a really great way to explore. So really take this opportunity to spend a bit of time, and don't just charge through the challenge. Why not explore the things that are of interest to you? And you've got data around culture, you've got tags, you've got mediums, you've got certain periods of time based on the artist end dates. You've got loads of different things you can filter. So just take the opportunity to explore. It's definitely worth it. why not
Yeah.
set up your own virtual conferencing art viewing and collect some requirements from your friends? You know, this is so, you can have so much fun with this. So please do take the opportunity
Absolutely.
to explore as well.
When I played a little bit around with it, I had this you know this from Wikipedia, which you usually have when you start with one article and you read about it, and then you decided, oh, this is actually leading towards this other thing, and then you click on that, and then you read some more, and then you click on the next one and the next one. And then here is a similar experience. You click on one image because you find this is matching your criteria, and then you see this nice picture of something, and then you read the description. And there are at the bottom of the page there are related art pieces, so that you could look into that seem to be samey, or at least some sort of overlap. So then I clicked on this one, and you know how it goes.
No, absolutely. It's really fascinating to do that. It's what's quite amazing. I find is that how you can so quickly, you know, with very basic information, you can map things together. You can so easily set something up where you can just explore the things you want to see. It's like really like crazy. I mean, like it's a few cipher queries and you're good to go. I mean, that's amazing. Or with Bloom, hey, you just type the keyword and hey, bring it up. It is really amazing. So do have a go at that. Okay, so I think let's have a look at last week's solutions.
Yeah, let's have a look at that.
So starting off with the beginners challenge, so I shall hand it over to you, Alex, and then I will switch over for you to share your screen.
All right, sounds good. Yeah, so the beginners challenge was basically we wanted from you to model a Wikipedia page into a graph model on in Arrows or any other tool you like to use. The majority of people actually have used Arrows. Some people actually used browser, which is, I guess, for the more advanced people. But it's a fairly easy step, I think, to generate something in Arrows. We wanted you to use all the labels provided. We wanted to use sensible relationship types and no type repetition. And we would like to have a model that could provide an answer to the questions. So if we go to my screen, maybe.
Yep.
I can quickly share that with you what the process would have been for one model. So again, I say, and I show you some I liked, which we received, but I will show you one fairly basic model how to generate the model for the graph for the page. But obviously there are wrong answers. Don't get me wrong, but for this one, I think there's more or less no wrong answer really. If you get the answers in for the questions we wanted for you to see. So again, this was the page, original variations of barbecue, and once you start, you see here the list of content. So it goes into all these countries. So I started here already with a note that says barbecue. Let me add another one. Oopsie, this one, save, right? Maybe I refresh the page. Yeah, here we go. This one we should say country, and we can call this country. We can say name is country, so we could call it like. Let's look into the list here. Let's start with the first one here. Let's pick South Africa. All right, so we have now created a node country with name South Africa, and we have here this barbecue in the center. So now we create a link between, or a relationship between the country and barbecue. And then we say the barbecue is a cooking type for this country, or is from this country. Maybe this even makes more sense. So, but this direction now is not really the right one. So we reverse the direction and we say, okay, barbecue is from South Africa. So we know, okay, this is now the South African type of barbecue for, oops, this was a little bit too small. So here you go. Next up, we talk about what kind of barbecue is it. So there are various types of barbecues, and this one we have here is the word braai, is a African type of barbecue. So with this answer to this question, we can give it let's call it the cooking type. So here we go. Back here, I create another node. And this one is supposed to be called cooking type. And this is maybe let's call it style. And again, braai is the kind of style we have. So we add that here. And now we add that cooking type to the barbecue as a relationship and connect that. And we can call this maybe is like cooking, or let's call this cooking. So this type of barbecue is using the braai style to cook the food. Then we look into then go back to the page and say, okay, this is here. Here it says, while wood was formerly the most widely braai fuel, modern times charcoal, briquettes, and gas. But we say, okay, the formerly most widely used fuel was for braai was wood. So let's go here and say, okay, we add another node, call this fuel, and this is type maybe again, and we can give it a name and we call it here. This is wood. So right, for this braai cooking type, we use fuel. So we connect these two again, and we can call this maybe uses. So the barbecue from South Africa that is of type braai uses wood to fire it up. Next up, we wanted to know what kind of cooking surface is used. So if you look here at the picture, or I think it's probably surely at the text as well, is some kind of grill. So it's not a flat surface or a hot stone or something else. So it's a grill. So we add that as well. Call another node here. Give it a name. So let's say cooking surface. And we give it a type and say, okay, this is a grill. We add this here. So again, relationship between cooking and cooking surface. So barbecue, and we call this maybe has. So this, or maybe even better, cooks on. That's maybe clearer then. So we have the barbecue that cooks on the cooking surface, which is grill. And now we have the little graph together. The only thing what we need now is missing is what is actually going on that grill. So we see here that in this South African braai is this kind of whatever is there. So it is like a potluck style. So you can bring whatever you have, although chicken, pork, and lamb chops steaks are kind of like the predominant selection. So it's not as vegetarian as some other styles. So let's go with chicken, for example, and we say, okay, we have here the food, what comes in, and then we have the ingredient. Ingredient is chicken. So here comes the barbecue that is, we call this maybe let's use cooks. So we say, okay, the barbecue from South Africa with fuel wood on the grill cooks chicken here in this example. And we wanted to know the dietary type, which this means. So we add another node, call it dietary. We call this type, and this is obviously carnivorous. How do you write this? Carnivorous, like this. And this is now the dietary type, and this comes off from the food node. So the food node goes into dietary type, and this is, call it, is off. And then this is our, it's very basic, but this is basically already what we wanted to have from you. So we now have the barbecue. We can now answer the question, what kind of food is on there, what kind of dietary this food is, what cooking surface uses this barbecue, what fuel uses this barbecue, and what cooking type is this barbecue of, and then obviously where is it coming from, which country it originates. And this is basically what the graph would look like if you were to import this or work this out in Neo4j. And we received a lot of submissions from the easy challenge this last week, and I have picked a couple which I thought were particularly well done and give good insight of, because this is very basic, and these three I will show you now quickly are going into a little bit more details. So here, for example, this was sent from Niklas. He also takes the barbecue as the center challenge, and he picks the one coming from Argentina, and he added some more details. So he was really fleshing it out a lot to have more details. So he even gave this a weighted relationship. So we see, okay, the barbecue is used in Argentina and is very popular in Argentina. So 97% of Argentinian people like to do a barbecue every now and then. And then what I also found interesting was here how he modeled this, the cooking type and the fuel. So he connected the cooking type directly with the node fuel here, with the relationship, can use fuel, but he also uses the prefers fuel relationship between the barbecue here, the asado a la parrilla, with the fuel type charcoal. So this is interesting because, like I said before, there are different kinds of fuel for different kinds of grills. So sometimes it's gas, sometimes it's charcoal. For the South African one, it was wood, which was the one that is traditionally used. Sometimes it's even like a electronic kind of grill power. And then technically it probably works with different kinds of fuel, but the one that is best for this kind of dish is, in this case, charcoal. I guess there's always this debate, gas or not, but I mean, gas makes things easier. But charcoal is obviously for this one the preferred one. So you can always decide what you want to do or what you want to use. Maybe next one here is from Jean-Philippe. He also added all the nodes that we wanted to see from the question here, but he also added lots of different properties to all these nodes. So he gave us more information from the page that is technically then available for you in the graph. So, for example, here, as the preparation style is here, you have certain types of marinades or coverings, and then you cook in olive oil or something like that. Or here, for example, the cooking type. He added the temperature and the duration and the flip rate. So how hot do you need it to be on the surface, and how long does the whatever you use, meat or vegetable, have to be on that grill. So I think that's really interesting and shows you how much more information you can add to this one node in the properties, and then expand what you know a little bit more. And then last but not least, Mike. This is a little bit small, but it gets unfortunately gets a bit blurry. But when I zoom in, but what he also did and what I liked as well was he added the popularity as well as a weighted relationship between the nodes. So he added here in the United Kingdom. Chicken souvlaki is a popularity score of 3.9. Barbecue has a popularity score of 4.5. So you can say, okay, I want a recommendation of something. So I want to see. I'd like to do a barbecue in the UK, and what kinds of grill barbecue food and what kind of dishes are very popular, and then we can get a ranking back from that. So that's that's super interesting for a recommendation engine for you, for example, if you want to get more. Yeah, I think that's all I wanted to show, a little rundown of the various submissions of how the general graph would look like if you go really from a generic and basic line, or some examples where they added a little bit more flavor to it. I think back to you, Lou.
Thank you. I found the description about the UK where houses don't have air conditioning. As I sit in my sauna room with the window closed and like my face is like dripping, and it must be about 38 degrees in here. I thought, yeah, true that. Okay, thank you very much, Alex, and thank you very much to everybody who took part in the Beginners Challenge.
Absolutely, thank you.
Yeah, we really hope you found that interesting, fun. If nothing else, you learned something about barbecues as well. Oh my goodness. I could do
some inspiration for weekends at least, yeah.
Oh yeah. Okay, right. On to the Experience Challenge. So this was all about planning for that socially distanced barbecue. And if you remember, we had this, effectively what we had a list of about 20 guests, including the host from different households. And we had 6 of these tables where they had 6 places, and each place is a metre apart. So we had a number of solutions for this. So this seemed to be a bit of a challenge for all of you. So hopefully, if nothing else, you had a good opportunity to learn about some of the APOC functions, and just it was a good bit of logical fun, I think is the best way to describe it. So it's a bit of fun. Maybe perhaps we could have made it a little bit simpler, but thank you for persevering. Hopefully you enjoyed the process. So we had 6 of these tables, so perhaps let's revisit what happened. So we had 6 tables with 6 places. If you had a number of households and 20 guests in total, and we said that you couldn't have more than 2 people from the same household sitting at a table. You couldn't have, everybody had to be socially distant, so if you're from the same household you could sit next to each other, but if you were from different households you had to have at least 2 metres apart from each other, and so forth, so etc, etc. So effectively, based on this table that we've got here, we've got a number of ways that we can sit this. So we can have one option here, so same colour means it's persons from the same household, so we could have a maximum of 4 people, provided that the 2 people from 2 households. That was one option. We could make this work and meet the rules. Another option was we could have 3 people from different households, but just 1 person each. They could also sit around the table, and that would meet the requirements. You could have 2 people from the same household and 1 person from another household, and again, that was fine. Or you could have 2 people from 2 different households. So all of these combinations, any one of these combinations would meet the criteria. So there is a number of ways to solve this, and indeed there were other approaches used. So there is more than one way to solve this process, and I'm just giving one approach that I used to solve it. And what I did was I used weights. So bear with me as I talk through the calculation of the weights. So I had this idea of a total weight. So a table could have a total weight which it could not exceed. And this was based on what was the total distance available on the table. So in this scenario here, it's 6 metres. And then we divide that by the minimum distance separation allowed. So 2 metres in this example. So this gave me a total weight of 3. Then what I followed with, the sort of thinking behind this, was we then assign a household weight. And this was based on the number of members in that household divided by 2 plus a half. So as an example, if there's 1 member in a household, it would have a weight of 1. If there were 2 members, it would have 1.5, and so on and so forth. And so effectively, I assigned the weight to all of the households at the point of loading, and then used the household weight to split out subcategories. So this was my pre-processing, and again, we did have entries where you were doing the processing of the households at the time of running seat allocation. Kudos to you, that's really, really good. I took the easy way out, and I decided I'd do my pre-processing prior to doing the seat allocation, which is fine. So I'll show you the queries that I've used. That's an iterative process. So I then use the household weights to split out sub-households, so that in the end we were left with households that had a maximum weight of 1.5, and then we use these households to allocate households to tables based on these weights. And another assumption that I've used is how internal node IDs work. So basically, when you load up a bunch of nodes, they're going to get they typically tend to get consecutive node IDs. So if you then create another node, I'll create a new node when I'm splitting up households, it's not going to have a consecutive ID with the household it's been split from. So that's the rationale that I've used to work around that. And here you've got a sort of basically a model of how how a node of data eventually looks. So this idea of a guest is a member of a household and it's located at a table. And then the idea is that table's got some kind of a weight and the household's got some kind of a weight. So without further ado, let's have a quick look at what I did. And again, there are many ways to solve this, and people solve this without using weights. So there is more than one way to solve it, and certainly if you feel like having a go at solving it in different ways, please do. So I'm just going to do this via sandbox. So I'm launching a blank sandbox.
This is maybe while you launch it. This is if you are doing the easy challenge for next week and you want to know how to launch a sandbox, look what Lou is doing.
Yes. So we've put a video, and now's a good time to sort of keep your eyes as well, because what you'll spot is we've now got Bloom on a blank sandbox. Aha! So for next week's challenge, everybody who's doing the beginner's challenge, do it on sandbox. You've got access to Bloom. It's all at your fingertips. So just going to start browser here, and then we're going to run these queries. Oh, we've got somebody from Brazil. They'll be able to tell us all about the Brazilian barbecues.
Yeah, probably.
I'm going to guess that's a lot of meat and not much vegetarian.
like the Argentinian one we looked at earlier. Yeah, it's in South Africa. I think barbecue in general is tends to be lots of meat and lots of that kind of thing without any vegetarian options really. But well, that's how it is. I think it will come.
Yes. So let's talk through the queries. So first pass here, what I'm doing is I'm loading the household data. So I'm pulling from the CSV, I'm creating a person, I'm putting the name in there. I'm merging the households because obviously there's more than one household mentioned, because obviously you may have multiple names. So I'm merging the household and I'm taking the ID. And then what I'm saying here is when I create a household for the first time, I'm giving it a weight of 1. So if I'm creating it the first time, it means I'm associating it with one person. So half a weighting point for the person, half a weighting point that we add per household overall. And if it's a match, so that node's already been created, then what I'm saying here is I'm going to increment by half. So I'm incrementing per extra person that joins the household, and then I create the relationship of person is in the household. So that's me loading up the persons and the households and setting the weights. Next part, I'm terribly using APOC periodic commit, but the next stage I'm doing is I'm now splitting up my households where there is more than 2 people in that household. So now that we know that a weight for 2 people in a household is 1.5, we want to match all households where the weight is greater than 1.5. And then I'm doing this one by one household, so just get the first household. Then I now want to match all of the people in that household. So I've been a bit lazy enough not putting the labels, so I'm putting in a tag for relationship and a tag for person. And with everything limit 2, so that's just going to grab 2 people from the household. So 2 relationships, 2 people. It's going to limit that query to, and it's going to put it through. I'm going to create a new household node called basically the ID of the original household plus the weight. So I'm using this as a way to provide a distinct ID for that household, and the weight seemed like a sensible thing to pick. and I'm going to set it a weight of 1.5. So we've got 2 people, so that's why I've got a weight of 1.5. And then I'm going to merge those 2 people to a new household. I'm then going to delete the existing relationship that those 2 people had with other households. So, for example, let's say we had a household of 3 people. So we're going to take 2. We're going to put them into a new household. Let's say the household was D, so it's going to become now D. D2 2.0 because that was the original weight, so that's how we're setting a thing. We delete that relationship from the existing household with distinct H, because bearing in mind we're going to have 2 H's because we had 2 relationships, so I'm just saying taking 1. I'm now reducing the weight of that household by 1, and then you return count 0 because you need to return something so that APOC knows when it hits 0 it's finished. And the idea is that we can keep iterating through until we've dealt with all of those households. So that was to split up the households. And then last but not least, to create the tables. So we've got 6 tables, so I'm just doing range 1 to 6. Unwind that as a set of numbers, and then I'm setting my tables. And I'm setting all of my table weights to 0. So this is the table, it means 0 means no one's been allocated at that table. So let's run that and create that all up. And then last but not least, let's allocate some seats. So what I've done here is, again, I'm using APOC periodic commit, and because I'm limiting it by 1, it means it's only, I'm going to keep putting this limiter here, so I'm always going to pull just 1 item and process it, and like that, that's how I'm cheating to iterate over and over and over until the function's been completed. So again, I'm matching households where households have not been allocated to a table. So I'm just being a bit lazy here. I've not used the relationship type or node label here. So here I'm ordering by weight. So what I'm doing here is I'm forcing the ordering by the largest number. And the reason why I do that, and again, because we've not specified but equally balancing tables and things like that, is you want to make sure you pack those tables up first so you've still got enough tables to make sure everybody is seated. So that's the approach that I've used. So again, that the household with the highest weight, and I'm also ordering it by ID to try and force that the 2 households that we've split out don't end up next to each other. So if I do an ordering by ID, then they shouldn't be next to each other, so we don't inadvertently put them on the same tables. So we're doing that, and I want to match a table where the total weight of the table plus the weight of the household is less than or equal to 3, because if it's greater than 3, then we're going to exceed what we're allowed to put on that table. And then again, sort of limiting by 1, so grabbing 1 table, and then I'm putting the household to that table. I'm now updating the weight of that table and returning it. So we just keep going around until they've all been allocated. And then this is a bit of a fudge to make sure it finishes in 1 query. So I'm yielding updates, but I'm not going to do anything with them. I'm just doing this so I can continue my query. And here I'm matching persons that are in household that are at table. And we've not asked you to do collect, so don't panic if you see a collect. I'm just doing this so you can see the visuals about who's been allocated where. So I'm going to collect the names as guests. I'm going to collect the IDs. And I'm doing a bit of a fudge here, so if I know that all the households start with a letter, so I'm grabbing the letter as the household, and then the table number, and ordering by table number. So hopefully this will run, and there we go. And there are allocations, so you can see here we've got our allocations. Nobody sits on their own. We've got a maximum of 2 people per household, so that is one way to do it. Don't worry, all of those queries are in the week 1 blog post. So week 1 blog post has been updated both with sort of where Alex was covering the doing the data model and with the
forum. And then we get in touch with you.
Indeed, and don't forget to explore those amazing paintings. Let us know which ones